So we just need to make a deep copy of a given linked list. So you will be given a linked list. It has next node and random node. So we have to make a deep copy. So you will always be given a head of the linked list. You must make a deep copy. So let me explain how they are trying to what they are trying to say. Let's say, so you will be given a linked list node, something like this. We have one. So till now we worked on. So this is how we worked. So we have, this is our linked list. So we have node 1 and it has next node, and let's say we have node 2 and it has next node. We say, let's say we have node 3. So till now we just worked on next pointer. So this is my next pointer, and we also have a random pointer. So this is my random pointer. Node 1 is also connected to node 3. So similarly, node 3, let's say you have next pointer as 4. Let's say you have next pointer as 4 for 3. So 3 next is 4, and node 2 is also connected randomly to node 4. So what we should do is we should create a deep copy of this list. So your node will have value, next pointer address, and random pointer address. So we should make a deep copy of the same linked list. So how do you do it? So overall, how many nodes you have? Overall, how many nodes you have?
4.
There are 4 nodes, right? So we have 4 nodes. So we should create a same linked list, and it should follow the same structure. Deep copy means what? Don't reuse the nodes. So you should create a fresh 4 nodes with the same values, and it has the same connection between other nodes, next and random. Is the problem statement clear?
Yeah.
Yes.
So how do you do it? Forget about random node. Let's say you have only 1, 2, 3, 4. If you want to maintain a deep copy, how do you do that?
Again, create a um, new node and
Yeah.
start copying the values.
So it means you just traverse through this. You will create
Yeah.
node 1, then you will also create node 2, then you will also create node 3, and then you will also create node 4. Correct? So this is a simple traversal, right? Correct, no?
Yes.
Yes.
Right. Now, so this is simple, and what is the additional thing we should do here? What is the additional thing we should do here? So from the above
That.
list, so node 1 is randomly connected to node 3, correct?
Yes.
And node 2 is randomly connected to node 4, right? So node 2 is randomly connected to node 4. So if somehow, so from this base list, right? So assume that this is my base list. So this is my base list. Somehow this base list is having actual node, right? Correct, na? This node and this node both are different, right? Yes or nobody? This is deep
Yes.
copy, right? Yes or
Yes.
no? So this is deep
Yeah.
copy. And this node is both are different. But you know that from the base list, to random is this node. And what is the new node mapped to this node? If you know that, then we can easily make a connection, right? Yes or no?
Yes.
Kalyan?
Can you please come again?
This is the base list, no? This is the base list. Mean this is the list which is given in the problem statement. So if you wanted to make a deep copy, one thing is very clear. We can simply traverse and have a
Yeah.
same list.
Yeah.
But in order to map the random list, so if you see in the base list, 2 is connected to node 4, right? And
Correct.
this node 4 and this node 4 both are different, right? This node 4 is the base node, this node 4 is the new node which we created, correct?
Yes, correct.
So
This is-
somehow, so from the base list, I know what is the random node, correct?
Yes.
So from base node to random node is 4. Somehow, what is the new node is mapped to this 4. If I know that, then I can easily connect, right?
Yes.
So for this node, what is the new node which is mapped? So if I know that, I can simply make a connection here. And similarly, I can make a connection here. So how to do that?
Index.
Index?
Based on index, we can
No.
set.
Okay, if you know index, okay, but to find out that node again, you need to traverse, right? Yes
Yeah.
or no? And that is going to take definitely log n time, right? So your time complexity leads to n square. Then what is the alternative?
Actually, why it would be n square? It would be order of n, right? Let's say we traverse the base one again and pick the random
Okay, so
one,
let's
random
say
node and
initially,
copy.
okay. First of all, how do you maintain index? Tell me. Okay, this is the node. Akash, tell me first, how do you maintain the index? This is the node 4, right? So, which is mapped to this one. How do you know that? Based on index.
We are copying in the same direction, right?
Hmm?
So, one solution could be copying everything to a map and again reconstructing the all nodes on the map.
That's the so okay. So you have a map. So what is the map structure? What is the key and what is the value?
Node and node, both will be node.
Which node is the key? Both are nodes. Which node is the key?
Yeah.
Which node is the value?
Here one would be the key.
It means
And
base
what are the
node is
next
the
is the-
key. Base node is the key. New node is the value, right?
Yes.
Right? So base node
Yes.
is the key. New node is the value. That's it, nobody. So if you know, if the base node is already for this base node, if you already created a new node, you just return that new node. Otherwise, create a new node and add it. So let me explain here. So this is our base list, right? So you have 1, 2, 3, and 4. And you have a random list. So 2 is connected to 4, 1 is connected to 3. So first what I will do, so this is the base list which is given. So first what I will do, I am going with simple map. So this is my map. Map will have two nodes, key and value. So key is going to be the base node which is given from the input. So value is going to be the new node, whatever new node we are going to create. So first of all, we start from head. Okay, so I start from head. So one is not present in map, so that first I'll create a base node 1. For this base node 1, I have a new node as 1. Okay, this is my new node. Okay, both are not same, so this is my new object node. Okay, so this is my new node. So what I'll do, first I'll mark this one. Okay, nice. Then I'll move further. Okay, now if you closely see, 1 is also having random pointer. So 1 is having random pointer, which is 3, right? So is 3 base is not present here? No, it's not present. So that I create a base node 3 and which is connected to new node 3. Okay, so what I'll do, so first I will mark closely understand. So this is my 1. Okay, this is my 1. So this is my new node because 1, this is the base node. This base node is mapped to the new node 1. So okay, I have 1 here. Now this one is also having random pointer, so random pointer is 3. So 3 base node is not present in the map, so for 3 base node you also have new node. So what I'll do, I created 3 here. So definitely for 1 random is 3. Okay, nice. So I'll move on to the next pointer. So this is my next pointer, so which is 2. So which is 2. So now 2 base node is present, so 2 base node is not present in the list. Closely see, 2 base node is not present in the map, so that first you create a base node 2 which is mapping to the new node 2. Copy that new node here. Okay, so I copied. Then I'll move on to the next. So 2, yeah, so 2 is 2 next is 3. Okay, fine. So 2 next is 3. So when you are finding the next node, I am making things little complicated, so let me explain in a simple way. Okay, so let me explain in a simple way. Okay.
Shrinu, the new node in the first iteration will just hold the value. It will not have any next or any random.
Yeah,
Then
I
we'll do a
understand
second
that.
iteration.
Yeah,
Yeah, then we'll assign it then.
Yeah, one simplest solution could be this. I thought of doing in single iteration. Okay, one simplest solution could be, for every node you can easily traverse, right? So these are our base nodes 1, 2, 3, 4, and the values are new node 1, new node 2, new node 3, and new node 4. Done. So first you traverse this complete list, traverse the complete list and fill the map. Okay, in the second iteration what you can do, so second iteration you are going to construct a new head. So that first you have 1. Okay, so 1, what is a copied node? So 1. Okay, what is the next of it? So okay, so 1 copied is 1, so fine. So 1 is having random pointer, so that 1 random you mark it as 4. Okay, so 1 is also mapping to the random pointer which is 3, so which you mark. Hope you are able to understand, right? So you have node 1, so you have node 1 here. Okay, so this is my base node. Okay, what for base node 1, what is the new node is created? 1. Okay, so just take that 1. Okay, so here also you will maintain current, here also you will maintain current. Assume that this is C1 and this is C2. Now C1 random is 3, so that make sure that this C2 random also, what is the node which is copied to 3, so just take that 3 here. So it means you marked C2 random also 3. Okay, fine. Now let's move on to, let's increment the C1, increment the C2. So now if you closely see, C1 new node is new node base node 2, so which is pointing to this, so that you can simply say C2 next also same. Simple, man. So C1 next and C2 next, you just get it from the map and assign it here. That's it. So now if you closely see C1 random is pointing to 4, so that in this case C2 is also present, C2 random is also pointing to 4. Then just increment the C1 and C1, hope you are able to get it right.
But not that clear actually.
So this is first part is clear, right?
Yeah, first part is clear.
First part what we did.
So actually I'm not getting it clearly, that random thing.
Because there are 2 pointers, right? So in the linked list you have 2 pointers, right?
Yeah.
So one is next, another one is random. You need to construct a same relationship while making a deep copy.
Okay.
So what you do, first you start from node 1. Okay, so I started from node 1. What is the copy of the node 1? So which is 1, so take that 1. Take that 1. Okay, so Does node 1 is having any random pointer? Yes, it is having node 3. Okay, take that node 3 value, so assign it as a random pointer for node 1. Okay, so because here node 1 is having random pointer node 3, and for the new copy also you should have it. Let's move on to node 1 next. Okay, node 1 next is 2, right? And same you should make sure that you should maintain the same relation to the newly constructed node also. So that for 2 the random pointer is 2, so make that, sorry, for 2, for node 1 next is 2, so that for newly constructed node 1 next is also 2. Now again you see that 2 is also having random pointer 4, so that here you will mark that 4. You already get that so this two random is returning this 4, this 4 mapped value is this 4, so you will just construct it. Then you move on to the next one, you will move on to the next one, so which is 3, so which is also next to the newly constructed one, so here also you will get 3, and 3 doesn't have any random pointer, so that obviously you will move on to the next one, so that 3 next is 4, and for this 3 also you will move on to the next, which is 4. Clear, buddy?
Yes, it is clear now.
So there is no conceptual code here, but how do you write the logic is the critical part here. So let me do that. If you go with recursive, it will definitely. Okay, so let me do one thing. You can try this refilling the map once and doing the iteration one more time, the way we discussed on the algorithm. So let me write a recursive code which will do the both the things at the same time. So how I'll do, so this is my node, this is my node, so I'll just make a copy random list of this is my node head, and I'll also need a map, so which is of node comma node, so this is my lookup map. Okay, so what can we do? First I will check for this node, so this is my base node, right? So I can take it as a base node. So I'll check in the lookup map. Yeah, so if my lookup map contains key of base node, so contains key of base node, so I can simply return it. Okay, so I can simply return lookup map dot get of base node, so it can return that. Otherwise what I will do, I'm going to create a new node. So node, you can say new node, which is going to be new node with the same value present in base node. So base node dot value, and what I will do, I will just insert this information into the lookup map. Okay, so lookup map dot put of base node comma new node. Okay, so base node comma new node. So finally I must and should return whatever new node I created, so I just need to return that. Okay, so now what should I do? I will move on to the next next one, so that what I will do, so this new node dot next, which is equal copy random list of base node dot next, then same lookup map. Okay, so then the same lookup map, so that's how I'll just move forward. And finally, once everything is done, whatever this is my new node, right? So new node dot random, which is equal, I need to get the random value. So if it is present in the lookup map, it will just return it. So lookup map dot get of base node dot random. So base node dot random, that's it. So it will just solve the purpose. If it is head equal to null, or if base node is equal to null, it means you are reaching to the last pointer, so you can simply return null. Are you understanding? Did you understand the code, buddy? So it's the same concept, but I'm just handling through simple recursive code. Going with iterative approach, I feel little complex here. So let's see. Now what can we do? Yeah. Just simply return copy random list of head with new hash map. Yeah, so that's how it works. Hope you are able to understood this. Yeah, so do you want me to explain this recursive code or you get it?
This is fine.
Got it, Shrinu.
Yeah.
But our algorithm is different. We discussed in different algorithm, but it's fine. You can try that iterative approach too, but it is very tough to traverse between the nodes. But still, that will also work. You can simply convert this code into iterative approach. You will simply get whatever algorithm we discussed. Okay, so let's move on. So we want to sort this list. So you will be given a linked list, so which is to be sorted. How do you do that? So you will be given a linked list, so which is to be sorted. So let me give you a linked list. Let me explain here. So let's say you have a linked list called 7, 5, 8, 3. Okay, so this is your linked list. So let me 7, 5, 8, 3. So let's say this is your linked list. So you need to sort it. So how do you sort it, buddy? So the resultant linked list should be 3, 5, 7, 8.
Let's sort.
Yeah, how do you do that?
We can split into two halves.
How do you split into two halves?
By taking slow and fast pointers.
That's it, right? So this is slow and this is fast. So first you need to split this one into two halves. You know that when slow goes one step, fast will go two steps, right? And when slow takes one step, fast is out of here, right? Okay, so let it be. Let it be. So, or let me take odd number. It's fine. So let's say you divide it into two halves. So let's say you have two lists now. So one is 7, 5, 8, other is 3. Okay, so other is 3. Now again you need to divide this into, so you don't have anything to do here, so you can divide this into, let me take somewhat huge number so that it will be easy to understand the concept of merge sort here. So does it give any big one? Okay, so let me take here more or less. Let's take, let's say if you have 7, 5, 11, 3, 6, and 9. Okay, so what we can do, this is my slow and this is my fast. So definitely slow, when fast comes here, slow is here, and in the next step fast will be here, slow will be here. In the next step fast is out of here, so slow will be here. So obviously on the left part we will have 4 lists, 4 length. On the right part you have 6 9. Or can we do something else?
Generally we make this slow dot next to be the second list start, right?
Fast dot next, huh?
Yeah.
Fast is starting from here. Okay, so it is not dividing into equal parts, so let's change the logic. So slow is here, fast is here. Let's do that. So if fast comes here, slow will be here, and if fast goes here, slow will be here. Now if you closely see, we have 2 lists, so 7 5 11, and other part you have 3 6 and 9. Again you do the same thing. So again recursively solve left part and right part. So let's solve left part. So slow is here, fast is here. So when fast goes here, so definitely slow is here, so that we will have 2 lists now, 7 and 5, and you will have 11. Now again if you closely see, this is independent node, so we need to divide this. So definitely slow is here, fast is here, so that there is no movement of the fast, so that you can divide this into 2 parts, 7 and 5. And closely see, you have L1 and L2, so these two are independent, so it's time to merge these two. So once you merge these two, definitely you will merge based on ascending order, so that it is going to be 5 7. Now again you get if you closely see, this part is left, so this is 11. Now if you closely see, this is my L1 and this is my L2, and we need to merge these two lists. So once you merge it, so definitely it is going to be 5 7 11. Is this clear? This part is clear, buddy?
Yes.
So now it's time to apply the same concept to the right part. So we have divided and merged. So right part, so this is slow and this is fast, and obviously slow goes here, fast will be here, so that obviously you will get same concept. So 3 6 and 9. Again slow and fast, so definitely this is going to be 3 6 and 9. So first you merge these three, so that obviously it is going to be 3 6, and then this is going to be 9 itself. Now again you will try to merge these two, so which is going to be 3 6 and 9. Now this is sorted list and this is also sorted list, and again you will try to merge it. So finally you will get resultant list as so you will merge these two lists, so which is going to be 3 5 6 7 9 and 11. So finally that's the expected output, right? Did you understand how to write the logic here? Did you understand how to write the logic? Kalyan, Akash?
Yes.
Okay. So tell me, what is the time complexity here?
We are using login.
Login. So let's explain here. So let's say you have n equal to 8. So you are dividing into 2 halves, right? So which is going to be n by 2 and n by 2, correct? So in
Yeah.
each half you get 4 and 4, right? Again this n by 2 is divided into
2 halves.
2 halves, right? So definitely it is going to be n by 4 and n by 4. So if you closely see, which is going to be 2 2, right? So earlier here 4, so this is also n by 4 and n by 4. It means with respect to n by, so of course half of this 2 is means fourth time of given n, so which is also 2 2. Now again this is divided into 2 halves, right? Correct?
Yeah.
So which is going to be n by 8 and n by 8. So here you get 1, here you get 1. Similarly here also n by 8, n by 8. Here you get 1, 1. Same, n by 8, n by 8, 1, 1. N by 8, n by 8. So here also 1 1. Okay, so it means whenever you get a last node, so it's time for you to apply the conquer logic. So we just applied it. So what we did, so first we applied a conquer logic to this, then again we got a n by 4 to this, again we got n by 4 elements, then again we applied a conquer logic between these two, then again we got n by 2. So similarly here also we got the same concept. So here we got n by 4 and n by 4. So we applied n by 2, then again we applied a conquer logic, so which is returning n by 8, sorry, which is returning n. So that's what we did. Initially we divided it, then we applied a conquer logic. So if you closely understand here, of course, which is going to take log n steps. For sure it is going to take log n steps. That's perfect. Okay, so in each log n step, what are you doing? In each log n steps, what are you doing?
We are split.
So we are just dividing through log n steps. On each log n steps, what are you doing? We are also doing comparison,
then we are
right?
merging it back for each.
Yes. So the merge is happening through comparison, right? Yes or no?
Yeah.
So how much
Yes.
of comparison it is happening in each log n step?
N comparisons.
N comparisons, right? Because 4 elements, wherever you go, definitely you compare 4 elements, 8 n elements, right? Yes or no?
Yeah.
Yes.
So definitely it is going to be n log n, right? Because you
Yes.
have log n steps, and each step you are trying to do n comparison, so that it is going to be n log n. So what is the space complexity?
Space complexity also same, right? Log n.
No, we are not taking any additional space, right?
We are not taking any additional space, but we are initiating recursive calls, right?
Yeah,
Yeah,
for
it's a log
recursive call, yeah, it's the same order of n log, order of log n.
Yeah, so it's log n.
Log
Of course, you will initiate how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, lot of calls, but at any point in time, only log n call stacks are active, correct?
Yes.
So that's what. Okay, so let's do that. So what is our job now? Whatever head we get, so we will take list node slow is head, and list node fast equal head dot next. Okay, so prior to that, we will see if this is the base check, right? So if head is null or head dot next is null, so it means you got only null node or one node, right? So definitely you can return head, whatever head you got. Okay, so this is fine. Then what is our job? We have to divide my linked list into two halves, the given list into two halves. But what we should do? So simply we will just make sure that we will move the fast pointer, so where fast not equal to null, and fast dot next not equal to null, and you will just move slow by 1 and the fast by 2. Okay, now if you closely see as per our logic, once you apply this, so what is happening? Slow is pointing to the first list end, right? Slow is pointing to the first end of the first list, right? Correct now, buddy?
Yeah.
So once we are done with that, so slow is pointing to the end of the first list, so that you can focus. The slow next is going to be the second list. So that let's do that. So list node L1 starting from head. Okay, so starting from head, whatever head which was given, and list node L2, which is going to be the slow dot next. Okay, so you will get slow dot next. So as you separate it, so make sure that you update the slow dot next equal to null. Done. So you have separated two lists. Okay, so you have separated two lists. Then what is the job now? What is our job?
We need to sort and merge.
Right. So one you keep on do that. So again we need to okay, so we have L1 and L2, so we got L1 and L2, so it's time for us to so we again need to recursively sort L1, we again need to divide L1 and L2, right? Yes or no?
Yeah.
So let me do that. Sort list of L1. Sort list of L2. So is that what we are trying to do? Let's check on the screen. Okay, so what we did, so we got L1 and L2, and we are trying to sort L1 and sort L2, and then you are going to get a
line number 27, 28, we can directly write in the 23, 24 answer.
that we can
Sort
do.
list to sort list slow down.
Yes, we can do that. We can do that. Let me sorted L1. Sorted L2. So if you closely see, this is recursive code nowadays. So when you if you closely see, this is what we are trying to do, right? So let's say you have elements as 5, 3 and 7 and 1. So this is your elements. So first what you did, so you got 5 comma 3 and you got 7 comma 1. Then again you are trying to divide this into L1 and L2, so definitely which is going to be 5 and 3, and here also you got 7 and 1. Now you got so as it is 5, so definitely you get so this is the time to apply conquer. So that sorted so if you closely see, if head dot next is null, so we are just returning the same head. But obviously whenever you initiate a call to this, it will return 5. When you initiate a call to this, it will return 3. So this is SL1 and SL2. So it means sorted list 1, sorted list 2. So once you get it, so definitely you are going to apply a merge logic on these two, so that it is going to return 3 comma 5, and this 3 comma 5 will be returned. Then again you are trying to apply same thing. So here also you will get SL1 as 7, SL2 as 1. So you apply a merge logic on this, so that you get 1 comma 7. So once you get 1 comma 7, then you apply a merge logic on this, so that it is going to be 1, 3, 5, 7. Correct na?
Yeah.
Correct. So it means once you get sorted L1 and sorted L2, so on this sorted L1 and sorted L2, so you just need to apply merge logic. So once you apply a merge logic, and that value is going to be the resulted sorted list. So I need to write a merge logic. Is this clear, buddy?
Yeah, it's clear.
Ajay, Kalyan. Yeah. So I need to apply merge logic on this. So list node merge. So tell me how to write that.
Dummy dot. We need to take the dummy.
Yeah, so it's simple, right? So those two lists are already sorted, correct? Yes or no, buddy?
Yeah.
Whatever list you are getting here, which are already sorted. Okay, so carefully, that's the most confusing part in merge sort. So mostly we tend to get confused once we divide into possible parts, right? Then so once we divide it into possible parts, then we are trying to apply this conquering logic, right? So this is merge logic. So this merge logic is called conquering. So once we are done with right left side and we are done with right side, whatever result we get, so through which we are trying to do it. Okay, so that is the most confusing part. So please put some time while making a recursive code, recursive diagram. If I explain, you will get it, but better you spend some time. Okay, nice. So we have list node, dummy new list node of -1. Okay, you can ignore it. So list node current, which is going to be dummy. Can you tell me logic now? What is the logic now? Tell me. Tell me, buddy.
L1
what
not equal null and L2 not equal null.
So both should not be null. So both of them should not be null. Then you can check now if L1 dot value less than or equal to L2 dot value, then current dot next is going to be L1. Else current dot next is going to be L2. So if you assign L1, then move L1 to the next pointer. In case if you assign L2, move L to the next pointer. Then each time we will just move current dot next. Okay. So then finally, one of the list might be higher number, right? So if we have, so then finally you will just say current dot next equal. If L1 is null, then mark as L2. Otherwise L1. Then finally, what is your job? You need to return the sorted list, right? Sorted list head. So that is dummy dot next. Okay. So on the dummy next onwards, you will have everything. So this is simple merge sort on list. So that's it, buddy. You get it, right?
Yeah.
Actually, you guys are making my job very easy, bro. Even I'm not explaining clearly, you are able to get it. So that's good thing. That's how the DS should be. So the basics we should go very slow, and the advanced concepts you should give the. So if I explain a little bit, you just need to understand. That's it. Okay. Now tell me, shall we go with stack or sorting? I need to spend some time on sorting algorithms because here we need to apply some divide and conquer things. Let me talk about sorting once I spend little bit time. Otherwise, I cannot explain in a better way. So we can do one thing. Either we can start backtracking if you want, or we can start with stack. Which one you feel better?
Stack.
Okay.
Stack.
Backtracking, no backtracking. Okay. So let me.
I would say backtracking because stack is easy.
Yeah.
Today these two problems are fine.
Today, tomorrow and day after tomorrow we don't have session.
That's okay.
That's okay.
You
You joined 20 minutes late, and hardly you were in session for 40 minutes. Let's do one thing.
Stack problem we solved many times.
And better what you do is don't waste your time and try to solve these. I think first three problems you can solve on stack. If you are unable to do it, we can discuss on next session. Later problems I can explain. Okay, so you want me to stop the session now, or can we?
That's today.
It's overloaded. Ajay Kalyan.
practice also, right? So if you teach more than
Huh? Okay, no problem then. So let's meet on 15th. Uh, so don't be absent on 15th. We will discuss. We will decide which one to proceed. Then we will just move on. Okay. Please practice. Yeah. Thanks.